Good morning, everyone. My name is Stephen Farrel, and today I will be presenting a review titled Effect of Processing Method on Soy Milk Protein Functionality for Plant-Based Meat Applications. This review focuses on how different processing methods may affect or alter soy protein functional properties and why these functional properties are important for producing high quality and plant-based meat products. Now on to the next slide. It will be about background. Now, why this topic is important? Plant-based meat products have become increasingly popular due to the concern about sustainability, environmental impact, and health. As consumers seek alternatives to animal-based foods, manufacturers need protein ingredient that can mimic the texture and sensory and characteristic of the meat to be the same. So soy protein is one of the most commonly used plant protein because it has a high protein content and excellent functional properties. These properties include for example, like emulsification, which helps stabilize oil and water mixtures, while gelation contributes to the firm and meat-like texture of products, and therefore, understanding how processing method affects these properties is essential for improving plant-based meat quality. And now on to the next slide would be the problem statement. Problem statement, so for this topic is that although soy protein has been widely studied, there are still some important research gaps, such as for these studies, most of the studies for only focusing on one processing method at a time, and are performed under laboratory conditions. This means that the results may not fully represent what happens in real industrial production. So, in addition, there is limited research investigating how different processing methods interact when used together. Because of these limitations, more comprehensive understanding is needed to optimize soy protein functionality in commercial plant-based meat applications. On to the next slide would be objective. The objective of this review is to evaluate three main aspects. First, how different processing methods affect soy protein structure. Second, how these structural changes influence functional properties. And third, how the resulting functionality contributes to the development of the plant-based meat products. This objective helps connect the relationship between processing, protein, structure, and final product quality. On to the next slide would be the methodology of how this review paper is made. This is a narrative literature review. So this study was conducted as a narrative literature review. Scientific articles were collected from Google Scholar, ScienceDirect, and PubMed, using keywords related to soy protein functionality and processing methods. The inclusion criteria were peer-reviewed studies published between 2016 and 2026 that focus on soy protein functionality. After screening and selection, 15 relevant papers were included and analyzed. This approach allowed the review to compare findings from multiple studies and identify common trends. Next would be the processing methods. So, processing methods are in this slide provides an overview of the processing method that I've said earlier, discussed in the review. So this include heat treatment as shown in the table, ultrasound, high pressure processing, extrusion, and pH shifting. Although each method uses a different mechanism, they all modify soy protein structure. Structural changes can occur through denaturation, unfolding, aggregation, or change in electrical charge. This structural modification then affect important functional properties such as I mentioned before, solubility, emulsification, gelation, and water holding capacity. This relationship between processing structure and functionality is the central concept of this review. On to the next slide, we'll be discussing about the functional properties. Before discussing each processing method, it is important to understand the key functional properties of soy protein. Solubility refers to the ability of protein to disperse in a food system. Emulsification allows protein to stabilize oil and water mixtures. Gelation enables protein to form network structure that contribute to meat-like texture, or maybe like the juiciness of the meat, for example. Water retention helps products remain juicy and prevent moisture loss during cooking, similar as the gelation. Together, these properties determine the texture stability and overall quality of the plant-based meat products. On to the next slide, we will be talking about each type of the methods of the processing methods. So this one we'll be talking about heat treatment. Heat treatment is one of the most commonly used processing methods in the food industry. Heat causes protein to denature and partially unfold. This unfolding exposes previously hidden functional groups, which can improve interaction between proteins. As shown in the conceptual graph, actually I wasn't able to access the actual scientific graph, but from what I managed to gain from the information that I managed to gain from the paper itself, this is how it's supposed to look like. So, as shown in the conceptual graph, moderate heating generally improves functionality because it enhances solubility, emulsification, and gel formation. However, excessive heating, as can be seen on the graph, can have the opposite effect. Proteins begin to aggregate excessively, reducing their flexibility and functionality. Therefore, optimizing temperature and processing time is critical for achieving the best functional performance. On to the next slide, we'll be discussing about pH shifting. pH shifting is another effective method. In this process, soy proteins are exposed to highly acidic or alkaline conditions before return to the neutral pH, as shown in the diagram over there, like the flow chart. You can see that the extreme pH causes protein to unfold and alters their molecular interactions. When the pH is neutralized, protein adopt a modified structure with improved flexibility and surface activity. As shown in the diagram, these structural changes improve important functional properties such as solubility, emulsification, and gelation. Because of these benefits, pH shifting has attracted considerable interest as a protein modification technique. On to the next slide. This time I will combine the ultrasound and high pressure processing method. So ultrasound and high pressure processing method are considered non-thermal methods because they improve functionality without relying heavily on heat. That is why I exclude this from the rest of the method. So ultrasound works through acoustic cavitation, tiny bubbles form and collapse, generating forces that break protein, aggregates, and promote partial unfolding. High pressure processing works differently. It uses mechanical pressure to alter protein conformation and reduce particle size. Both methods improve soy protein functionality, but through different mechanisms. Ultrasound is particularly beneficial for solubility, while high pressure processing often enhances emulsification. Compared with traditional heat treatment, this method can preserve protein quality, while this still improving functionality, of course. Now, on to the next slide. We'll be talking about extrusion processing. This processing is actually pretty interesting because it's actually combining the wait, it's actually combining the heat, pressure, and shear. So what is happening here? Extrusion is perhaps the most important processing method for plant-based meat production. During extrusion, soy proteins are exposed to heat and mechanical shear simultaneously. Like I've mentioned before, if you're looking at the diagram over there, so this condition unfold protein and align them into organized fibrous structures. Well, particularly similar to how the heat treatment and pressure mechanism works. And then as shown in the diagram, soy protein is transformed into aligned protein networks, creating a texture that closely resembles animal meat. This fibrous structure is one of the most main reasons extrusion is widely used in commercial meat analog manufacturing. However, these conditions must be carefully controlled because excessive treatment, as I've mentioned before in heat treatment, could potentially reduce functionality because, of course, this extrusion method combines heat treatment and pressure and shear. Now on to the next slide. We will be talking about the limitations and recommendations for this research. This review also, most studies are conducted at laboratory scale. So that means use different experimental conditions. That means that it will make different or direct comparisons difficult. Furthermore, industrial validation remains limited. For future research, combined processing methods should be investigated. Functionality should be evaluated in real food systems, methodologies should be standardized, and greater attention should be given to scalability and economic feasibility. Now for the conclusion of this presentation is that processing methods have significantly impact on soy protein functionality. Moderate processing conditions generally improve solubility, emulsification, and gylation by modifying protein structure in beneficial way. However, excessive processing can lead to aggregations and reduce functionality. Overall, understanding and optimizing this processing method is essential for developing high-quality plant-based meat products with desirable texture, stability, and consumer acceptance. Thank you very much for listening to my presentation. Below here is the reference for the presentation itself. However, from the actual paper, there's supposed to be 15 reference. However, since I would like to summarize everything in the presentation, the reference would be a little bit smaller, like there's around 8 that I've used in this presentation. However, in the actual paper, there's supposed to be 15. Thank you very much for listening to my presentation. Thank you.